Hello CS271 students. Welcome to this video, which is going to provide a brief introduction to Visual Studio Code, which we will be using in lab on Friday. The first thing that I'm going to do is launch Visual Studio Code. I am launching this, of course, on Mac OS. Visual Studio Code is also installed in Halsey 101C, and you can download it from Microsoft. It's pretty easy to install. When you first launch Visual Studio Code, you'll see a welcome screen in the center. You may or may not see a sidebar open over here. The first thing we're going to have to do, and you're going to have to do this in Halsey as well, is click on the extensions icon here in the activity bar and do a search on Java. The extension you'll want to install is called Extension Pack for Java. Click on Install. Wait a moment or two. That was very quick. And then you now have Java available for your development needs. As a result of having installed Java, if you now click on the Explorer, this shows you and will show you all of the files in an open project. You will see that at the bottom you have a button called Create Java Project. Alternatively, you can press F1 to bring up what is called the command palette and just start typing the word Java, and then you'll see all the commands that relate to Java. So you can do create project here, you can do create Java project here, whatever you want. I'm going to click on this. We won't be using build tools for a bit, so we'll just click on that. It asks for a place to select the project location. I'm going to put this on my desktop. You can put it wherever you want. And now it's asking you for a name. I'm going to call this Lab 1. Ta-da! We now have a running Java program. You'll look here on the left-hand side in the Explorer. You'll see that there's a folder called, I'll always say this as source, it's SRC. Open it up, and you've got app.java. There is your program. You can press F5. You can also go to the run and debug sidebar, but usually what I do is I just have this open, I hit F5, and then you can see down here at the bottom, we've got this pane here is open, and it has problems, but there's no number here, so there aren't any problems at this point. We have a debug console, we have a terminal, and we have output. The terminal is actually where we want to go. That's where the output of the program is displayed. I am not certain whether or not you've talked about packages in CS171 or 221. Probably not. I'm going to talk a little bit about packages though. Packages are ways of organizing Java classes. And to make a package, you have to do two things. First of all, you need a folder with the name of the package in source. And then you have to put package at the top of the file that you want to be in that package. For example, let's suppose, so I just clicked here, by the way, to create a new file. This is the new file icon. Yes, you also could have done that from the menu somehow. And I'm going to create a class called cat. So I'll call it cat.java and then press enter. And then it creates the file and wants to know, do I want it to be a class, an interface, an enum, a record, an abstract class, or an interface, or an add interface? I want it to be a class. So I'll have this. I now have a class called cat. Great. Now I want to put it in a package called zoo. So what I'm going to do is, with source selected, I'm going to click on new folder, and I'm going to call it zoo, lowercase, because that is the convention for packages. And then I'm going to take cat and drag it into zoo. And when I do that, it actually writes package zoo for me. And so this is now in the zoo package. App.java, you can tell from the indentation, is not in the zoo package. So if I want to use something, I will have to say import. I can say zoo. I can import all of the classes in zoo, or I can just import one of them. Now, I have something turned on so that if I'm not using the class, it gets rid of the import statements, which is sometimes helpful, not here. So I'm going to have to do it the hard way. I'm going to have to create a cat. Let's see, a cat called Maurice equals new cat. All right, now it's mad. Oh, and then it went ahead and it inserted the import statement for me as well. Thank you very much. It's put this, it's underlined it because of the fact that Maurice is not currently being used for anything, and it's somewhat perturbed about this. This is not an error message. Error messages have got red squiggles. Incidentally, and this is a bit of an aside, if you want to control whether or not auto imports happen the way you just saw demonstrated, you can use the settings. So there are settings. You can access them in a number of ways. There is a cog down here. You can click on the cog and choose settings. And there are a huge number of settings in Visual Studio Code because this is a package designed for all sorts of different languages, not just Java. The trick is to remember the thing to search for. And I want to look for something to do with imports and maybe suggestion. No, let's try organize. Import and organize. And let's see here. I'm going to have to dig around for this a little bit here. Save actions. Enable, disable, auto-organize imports on save. That sounds sort of promising. All right, so again, I'm going to go to Java. I'm going to type organize imports here in settings, and I am going to disable this. That may or may not work. Save actions applies because I have chosen under the file menu, I have auto save turned on. So the file gets saved automatically, and then that causes the imports to be organized. A little bit complex, but not too difficult. Let's just go ahead and test this once more. I'm going to get rid of the cat for a moment. And this time zoo.cat persists. And if I were to type zoo.cat, it stays there, which is actually the way I want it to be. Now, we often use a package in this class that comes from the textbook, and we are going to demonstrate how to add files to Visual Studio Code. It is exceptionally easy. All you have to do is drag things into the source folder, and those things automatically now become part of your Java project. So to demonstrate this, I am going to hop over to our Canvas site, and I'm going to look for a file called sourcecode.zip. And I'll click on that and download it. And then once I've downloaded it, it's already unzipped. If we open up the file, the folder, we see that it's called source code, and it's got two packages, one called DSAJ and the other called net. I'm going to select both of those. And in Windows, this is going to look, of course, slightly different, but same principle. And just go ahead and drag it into source. Make sure you drag it into the source folder. Make sure you don't drag one into the other, like DSAJ into net and so forth. Once you have done that, those packages, so let's see here, if we take a look, let's see, the name of the package is actually DSAJ. No, that's wrong. There are two packages. The one that we're mainly going to be using in this class is the .NET package. The full name of the package is actually net.datastructures, okay? Because this is a folder and a folder within a folder, the name of the package is the names of the folders concatenated with a dot in between. So these packages are now available to us. To do something useful with these packages, I am going to open up in the DSAJ folder, I'm going to open up arrays, and I'm going to look at an insertion sort. Now you notice this has a main method in it. We're also in a class, or in a project rather, with app.java, which has a main method in it. So we're going to go back to insertion sort.java, and I can just right click and choose run Java, and then it's going to go ahead and then it just went ahead and sorted this array. Now, if I want to, I can do debugging. And debugging, of course, is an extremely important skill. To debug, all you have to do is with your code open, click on the left of the statement numbers and decide where you want to add a breakpoint. And then go ahead and instead of running Java, you can debug Java. By the way, normally when I run a program, I just hit F5. In this case, I'm not sure if I hit F5 if it's going to debug the right file. Typically, you only have one main method in an entire project, but I'm going to choose debug. It stops right here, and now we have switched in the activity bar to the sidebar for running and debugging. You can see we've got local variables. You can open up variables. You can add watches here. So I'm about to execute line 44, and I have two choices. I can click on this step over button, which means it's going to execute the entire sort instantaneously, or I can do step into. I want step into, so I'm about to call insertion sort, and now I'm in insertion sort. I'm going to get data.length. Right now, n doesn't show up here as a local variable. I see data because it's the parameter, but I don't see n because this is the line where it's declared. After I execute this statement, it goes ahead and shows me that n exists with a value of 12. And now I am in the for loop, and I can walk through the for loop. As these variables come into existence, I can study them. I can also add watches if there's a particular value that I want to take care of, that I want to sort of highlight. Let's say I wanted to know what data j is. All right. And then maybe data j plus 1. I can observe these values, and what the heck, I may as well just throw in j here as well. I can observe these values. I get a window into the program, and I can walk into the program. Debugging, and you can see things go out of scope, and so, or have to be recreated here. But debugging is really an art. It's also a mystery. It is also a tremendous amount of fun, especially when you're not under pressure. Hint, hint, start your labs early. A couple of other things that I want to point out. The versatility of the Visual Studio Code editor window, which is the window here in the center, is pretty incredible. So every time you click on a file, I'm just going to go ahead and stop this here. Every time you click on a file, it opens up a new tab. So let's say if I looked at scoreboard.java. But I can take these different tabs and drag them around. So let's say I wanted to have app.java here. Let me go back and open up my cat. There's my cat. And I can arrange it so I can have app.java on top, and I could put, let's see, I'll just drag in so I've got app here on the left, and then I've got cat here on the right. I could, if I wanted to, I could take that scoreboard and drag it underneath. You can see I can end up, let's see, I'm going to hop back to this pane now, and I'll throw in tic-tac-toe. Sure, we'll put tic-tac-toe to the right in this pane. So as you can see, I can organize these files in all sorts of different ways. I find it very useful when I've got a hierarchy to arrange these things so that the top of the hierarchy is here, the subclasses are here. Quite useful. You should take some time to explore Visual Studio Code. It is the most popular environment for doing development work. Developers just absolutely love it. Visual Studio Code is not the same as Visual Studio. Don't confuse the two. Easy to do, because one of them is called Visual Studio and the other is called Visual Studio Code. Visual Studio is, and I'm about to editorialize here, really, really bloated and cumbersome. Visual Studio Code is just magnificent. Sometimes you have problems with it, but that's just the way it is. Anyway, what you should do is, I'm going to go back to help, and you can go to documentation, and then it's going to, there are all sorts of resources here. I would take some time to study this, get familiar with Visual Studio Code. We use it in a whole bunch of different classes. You will see it in software engineering, for example. You'll see it in mobile, a whole bunch of different places, and so it's definitely worthwhile learning. That is it for this video. Thanks, everyone, for watching. And remember, you can always ask in class or office hours if you have any questions.